Alright, so we have an empirical formula problem here, and the first thing we're going to do is we have percentages. We're going to assume we have 100 grams of compound. That means these percentages will convert into grams, so 80.1% means 80.1 grams of Ba, 18.7 grams of oxygen, and 1.20 grams of hydrogen. First thing we do is we find out the number of moles for each that we have. 80.1 grams barium, grams of barium go on the bottom, moles go on top. Relationship, 1 mole is equal to 137.33 grams. And that's going to be 0.583 moles. We do the same thing for oxygen. Grams of oxygen go on the bottom, moles of oxygen go on top. 1 mole of O, 16.00 grams of O. That's going to be 1.17 moles of oxygen. Do the same thing for hydrogen. One mole of hydrogen, 1.01 grams of hydrogen, and that's going to be 1.19 moles of hydrogen. Next we figure out the mole ratios. We divide through by the smallest number of moles here, which is the moles of barium. So starting out with the barium here, we're going to do 0.583 moles divided by 0.583 moles. That's going to be 1, and that's for the barium. Next we'll do the oxygen, 1.17 moles. Divided by 0.583 moles. And that's going to be near enough to 2. And 1.19 moles divided by 0.583 moles. That can be rounded to 2 as well. So we're getting something like 1.99 or 2.01 here for these two. Alright, so that's for the oxygen, and this one's for the hydrogen. Since these are all whole numbers, then the multiplier is just going to be 1 right the way across. So the ratio here is barium to oxygen to hydrogen would be 1 is to 2 is to 2. So we're going to end up getting our formula as being BaO2H2, or if you'd like, BaOH